Hello everyone, once again I'm Akimbola Kende and I'm making this video as a follow-up from the video I made last week to document my journey as a Web3 developer here at the Web3 Bridge Learning Facility. I want to use this opportunity to say a big shout out to our mentors that has taken us so far, Mr. Beams and then Mr. Kelvin, aka Determinator. And I want to big shout out to Mr. Israel for giving us the opportunity to learn in this great citadel. So technically, I listed a couple of things last week in my video, but I didn't exactly talk about them in depth. So I'll just briefly talk about it. So what is blockchain? Blockchain is basically a list of records that stores transactions and all information cryptographically, and it is arranged in order in such a way that it is immutable. What I mean by that, it cannot be altered, it cannot be removed, it cannot be deleted. So that is basically blockchain. And although I would be emphasizing on the Ethereum blockchain itself. So basically, what is Ethereum? Ethereum is like the world computer. It's like a blockchain with a computer embedded in it. We call this computer the EVM. That is where all executions are being carried out. So what makes this Ethereum blockchain different from every other blockchain compared to the Bitcoin blockchain and the likes? The Ethereum blockchain allows us to build on it. Basically, if you compare it to the Bitcoin blockchain, all you do is just send transaction in and out, transfer ownership of cryptocurrencies and stuff like that. But Ethereum, it's not limited to just the transfer of cryptocurrency. It allows you to build on it, where that is when the concept of smart contracts comes in, the likes of your tokens, your NFTs and the likes. So I think that's basically that. And that's that for the week 0 and week 1. So we just finished week 2, which I would like to talk about. I would like to point out the things I learned in week 2. So we learned about the tabs. That's the decentralized application. So what makes these dApps special? If we look at the architecture of our Web2, we have the front end and you have the back end, which is the server side. But in the context of the decentralized application, we have the front end and then the back end as a smart contract. So the smart contract serves as a logic that sends, that fits the front end. So basically, this smart contract is built on the Ethereum virtual machine, which I said earlier, the EVM, which is built on the Ethereum blockchain. So whatever is being passed into the smart contract is being executed and processed by the EVM before it is being returned to the front end users. The likes of Uniswaps, the makers of dApps, Avi, those ones are financial decentralized applications. So yeah, that's just basically dApps. And last week, this just concluded week, we did something on the EIP and then the ERC. So basically, they're just adjustments to the Ethereum blockchain. And then although the EIP is with respect to the protocols at the protocol level, improvement at the protocol level, while the ERC is like improvement at the application layer, where you have your smart contracts, your tokens, your NFTs and the like. So we have different standards of the ERC. We have the ERC 20, that's for the tokens. We have the ERC 721, that's for the NFT, ERC 115. This one it combines the ideas of ERC 20 and ERC 721, together to bring out something beautiful. So also we talked about the Web2 Web3 architecture, what makes the Web2 world different from the Web3 world. We talked about that as well. And then we ventured into proof of stake. I made mention of proof of work, proof of stake last week, which I didn't exactly explain as well. So proof of work basically is like a means of adding to the blockchain in such a way that we have nodes that perform complex mathematical computation in an effort to solve for something we call the nonce. So the first person to get the nonce will be given the opportunity to push the next block into the blockchain, and then this validator is rewarded by newly minted Ethereum. So now I would like to branch somewhere just for a little bit. Now if it will come to your mind that if we keep minting new Ethereum for validators that had the chain, that adds a new block to the chain, if you keep minting it, won't it affect the Ethereum stuff, like economically? Now that is where the concept of gas comes in. When you make transaction, you pay gas fees. Now these gas fees don't go anywhere, or they get burnt. They get burnt. What do I mean by that? As you're paying the gas fee is like burnt, like gone, burnt into the thing. So that way it maintains the tokenomics of the Ethereum blockchain. That we're going to talk about some other time. So let's just go ahead to scaling. Oh, I would like to touch the proof of stake, because recently Ethereum blockchain transitioned from proof of work to proof of stake. Proof of stake is basically validators are selected to add a new block to the chain based on your economic prowess. What do I mean by that? Before you can be a validator under the proof of stake consensus mechanism, you have to stake an amount of ether, and the minimum you have to stake is 32 ethers before you can be randomly chosen to be a validator, to be a block validator. So as long as you have that, you can apply to be a block validator, and then you can participate. Although proof of stake is a lot more secured. What do I mean by that? Any form of dishonesty when it comes to validating the blocks will result into the slashing of your staked ether. So whoever is validated is always careful not to make the mistake of validating the wrong blocks or building on invalid blocks and the like, because any mistake will result into the slashing of your staked ether. And there is something I want to point out. There's a lot more stuff that are attached to the proof of stake. The concept of the committee of validators that would revalidate, that will recheck the whole transactions, because I would like to talk about how transactions are being processed, but then I will do that in another video, and I will give a detailed information on how transaction works, on how the consensus mechanism, how they carry out, how they decide on which block is valid and which block is invalid. So yeah, and then we talked about a basic problem in Ethereum. That's the trilemma, when it comes to scaling. The amount of currently the amount of transaction that Ethereum blockchain can accept per second is just around 10 to 15 transactions per second. Now imagine the whole world balloting to fit into that 10 to 15 transactions per second. It will make the network congested and a lot slower. So that is why scaling has been a serious issue. And then there have been several mechanisms to solve the issue of scalability. That's when we have the sharding. Those ones are on-chain scaling. What we call sharding. They break the network into several chains that we call shards. So each of these chains handle their own transactions and execution and stuff like that, and then they communicate with the main chain. So that is basically sharding, and I will talk about that in another video. I would explain it in depthly. So and then there are other layer 2 scaling solutions. There are several layer 2 scaling solutions. We have the roll-ups, the side chain, the plasma, validium, and the likes, which I will also talk about in another video. So this week we learned about them, and we learned about DeFi's, decentralized finance, non-fungible tokens, and the DAOs. So the DAOs are the decentralized autonomous organizations. So, and basically DAO is you're having a group of persons pulling resources together to okay, let's form this organization on the blockchain, and whatever decision we make, we all have to attest to it, approve this particular decision before it is being executed. So DAO is another concept on its own, which we learned and we talk about in another video. But then get the concept, just get the idea. It's like an organization that everyone is equal. Everyone has voting power depending on the architecture of that DAO. So yeah, and the DeFi is the likes of Harvey. Harvey allows you to supply your coin as a lender, and you can also borrow. So it's trying to simulate the real life finance into the blockchain. Basically, what we are doing in the whole concept of blockchain is just we're trying to bring in the real life scenarios into the blockchain so that we can do things we do in real life within within the context of the Ethereum blockchain. So yeah, and then we talked about decentralized social networks. We know in the Web2 world we have the likes of Twitter, Instagram, and the likes. And imagine bringing something like that within the blockchain system. There are certain websites that are running dApps for decentralized social networks, and which I think is quite brilliant. So yeah, and we talked about oracles as well. Oracles basically are like APIs. They feed the smart contract information depending on the kind of information you want. Okay, let's say you're trying to like get information on the current price of Ethereum and USDT. You can make a call to the oracles, and then the oracle will make several calls to oracle nodes. Then they will get information. But then you need to note something. Oracles, the way oracle get information, it could be from a centralized authority or a decentralized platform. Now, centralized authority is quite faulty because you only have one source of truth, which can be erroneous sometimes. It is not always perfect. But then when you have a decentralized system, such that the information they get is not from just a single source. They get from A, they get from B, they get from C, and they confirm the validity before it is being sent back to the oracle contract, and then the oracle contract will now communicate with the user contract. So in a nutshell, that is basically all I've learned in this just concluded week, which is week 2, and although to a layman, it is the 3rd week because we start counting from 0 as programmer. So yeah, that is all for this week, and I look forward to learning more stuffs in the following weeks. Although we'll be moving into the coding aspects in the following weeks, and I will come back to talk to you guys about it. See you next week. Bye.